Now, this problem looks a lot more difficult than it is. But what I'm going to do is I'm going to rewrite the second one as, this is going to be 50r squared, actually r cubed, over 9 plus, this is the square root of 98r cubed over the square root of 9. So that the actual problem becomes 50r cubed over 9 plus the square root of 98r cubed, and the square root of 9 is 3. Now, what is the common denominator between 9 and 3? 9. So I'm going to multiply this guy by 3 over 3. So this becomes now the square root of 50r cubed over 9 plus 3 times the square root of 98r cubed over 9. So that over 9, you will have the sum of the numerators, which is 50r cubed plus 3 square roots of 98r cubed. So that over 9, I need to break these two down. So I just deal with the numerator first. And the square in, and this is going to be plus 3 50, I have a 25, I have an r squared, and a 2r. 3 times. Now, I need a 2r. If I divide 98 by 2, what do I get? 49. So that's my square. 49r squared, 2r. So I used the one that I simplified first to see if I'm going to get the leftover the same in a second. This is 5r, square root of 2r, plus 3 times 7r, square root of 2r, over 9. Which is 5r, square root of 2r, plus 21r, square root of 2r, over 9. And if I look at and circle everything but the number, I notice what I've circled are the same. So this becomes 5 plus 21 is 26r, square root of 2r, over 9. Now, if I could reduce it down, I would, but 9 is 3 times 3. 26 doesn't have a 3 in it. That would have been a 27. That would have reduced. But it's not. That was an unpleasant problem. I need to remind myself that I need more space to work this one. Everyone have this one now?
Yeah.
Yep, we okay? Yeah. Simplify each radical, each product, and write the answer in simplest forms. we're away from, well, semi away from addition and subtraction, kind of. And we're back to multiplication, and that's when we're going to say, yippee. That last one was a test. So if I'm looking at, this is the cube root, if I remember, we can take two things that are separate. We can, if they've got the same index, this is going to be 32x times 18x to the fourth, which is the cube root of, well, you know, I'm not that good, so 32 times 18 is 576 x to the fifth. Now I've got some work to do. The x's are easy. That's an x cubed and an x squared. It's that stupid number. I'm looking now at my cubes table, and if I go down to my cubes table, 576, well, you're going to be something smaller than 8 cubed. So if I look at now going through 576, divide that by 343, no. 576, divide that by 216, no. 576, divide that by 125. I'm trying to find a perfect cube, no. 576, divide that by 64. Yes! It's 576 is 64 times 9, with 64 being the cube. Whew. So this is 64, that's 9. So this then becomes, the cube root of 64 is 4. The cube root of x cubed is x. The leftover is the cube root of 9x squared. And by the way, that's exactly how I would have to deal with that problem, with numbers that are that large. I just pull out my handy-dandy little table and work my way backwards using my handy-dandy little calculator, because it does better than me. This is the distributive property, so square root of 7, so this says I've got 5 square roots of 7 plus the square root of 7 times the square root of 21, which is 5 square roots of 7 plus the square root of 7 times 21.
That first line, you're just rewriting it in the proper order after you distribute it, right?
Yeah. And 7 times 21 is 147. So it's 5 square roots of 7 plus the square root of 147. And good luck, I think 147 is prime. So that's all she wrote. You could try it. It's got to be less than 144. So I think if you go down through 121, 100, 81, 64. I mean, if I take a look at just 21, woohoo! Guess what? There's a square. Now, why would I say such a thing? If I look at 7 times 21, right? And that's what I multiplied. This is 7 times, what's 21? 7 times, there's a square. There's a 49. 49 times 3. Who would have thunk it? Not me. So, this is 5 square roots of 7 plus the square root of 49 times 3, just when we thought we were done, which is 5 square roots of 7 plus 7 square roots of 3. Ooh. So, not done. And that's only because I looked at 21 and I said 21 is 7 times 3. I have a 7. It wasn't the 147 that did it for me. It was this one up here. Looking at the 21 and saying, I got a 7 and 21. Well, the good news is most of the time when you deal with this stuff, it's not with numbers. You're dealing with it because you've got a formula. Well, this is a fan fave. This is square, so it's 1 minus 2 square roots of 10 times 1 minus 2 square roots of 10. And you're going to FOIL it. First, 1. Outer, 1 times 2 square roots of 10 is going to be minus 2 square roots of 10. Inner is 1 times minus 2 square roots of 10 is minus 2 square roots of 10. Last is going to be plus 2 square roots of 10 times 2 square roots of 10. Well, this becomes 1 minus 4 square roots of 10 plus 2 times 2 is 4. Square root of 10 times the square root of 10 is the square root of 100, right? So you can bring that underneath, which is 1 minus 4 square roots of 10 plus 4 times the square root of 100 is 10. Which is 1 minus 4 square roots of 10 plus 40. Or 1 plus 40 is 41 minus 4 square roots of 10. That was unpleasant. That guy needs to be moved over a little bit. Well, if we thought that one was bad.
Oh, no.
And I'm going to come down here. I should have moved that over just a little bit more. It's FOIL, so it's 2 square roots of 3x times the square root of 3x. That's firsts. Outer is plus 2 square roots of 3x times the square root of 2y. I have to put all this stuff in here, otherwise I'll get lost. Inner is minus 5 square roots of 2y, square root of 3x. Last is minus 5 square root of 2y, square root of 2y, and I'm just about off my paper. Well, this is 2 square root of 3x times the square root of 3x is the square root of 9x squared, plus 2 square root of 3x times the square root of 2y.
As you're doing it, can you point to the ones that you're doing?
Right here.
Okay.
So it's right directly underneath. Yeah.
Okay.
6xy minus, then 5, that's this guy, and then square root of 2y, square root of 3x is the square root of 6xy. And then the next one is minus 5 Square root of 2y times the square root of 2y is the square root of 4y squared. This is 2 times square root of 9x squared is 3x plus 2 square roots of 6xy minus 5 square roots of 6xy minus 5 times the square root of 4y squared is 2y. 2 times 3 is 6x. Now, if I circle everything but the number, because that's the only thing that's got radicals left, notice what I've circled is the same. So if I have 2 circles, subtract 5 circles, how many circles do I have? 3, yeah, negative 3 circles. And 5 times 2 is 10y, and that's all she wrote. That's enough.